Dear cadets, Assalamu alaikum. Welcome you all at my online class. I hope all of you are well by the grace of Almighty Allah. This is Maqsudur Rahman, lecturer in chemistry, Borishal Cadet College, Borishal. It is very necessary to keep yourself inside home along with your family members for avoiding the running pandemic COVID-19. Considering this prevailing situation, Borishal Cadet College is providing necessary academic guidelines and short lecture on specific link periodically. With this continuation, I am here for your online class. In this picture, what you can see, yes, this is a fuel cell, and basically this is a hydrogen fuel cell. So by seeing this picture, I think you understand what is our today's topic. Yes, today I am going to discuss on fuel cell, that is in electrochemistry chapter 3 for class 12, and this is my 6th session. So at the end of this lesson you will be able to define fuel cell. You can describe the different types of fuel cell, you can describe the formation of fuel cell, you can also analyze the chemistry behind fuel cell, and you can also analyze the advantage and disadvantage of fuel cell and battery. So first one, what is fuel cell? A fuel cell is an electrochemical device that produces electricity. You know that in a battery there is an anode and cathode, and due to the chemical reaction it produces electricity. Like battery, fuel cell also produce electricity, and the reaction that happens in fuel cell is at very low temperature and no combustion takes place in fuel cell. A fuel cell is a device that generally generates electricity by chemical reaction, and every fuel cell has 2 electrodes. You know that a battery has 2 electrodes, one is cathode, another one is anode. Like battery, a fuel cell also has anode and cathode, and the reaction that produce electricity takes place at the electrodes. And every fuel cell also has an electrolyte. You know that in every battery there is an electrode, 2 electrodes, anode, cathode, and electrolytes. So like a battery, in a fuel cell it has also 2 electrodes, anode, cathode, and also has electrolyte, so which carries electrically charged particle from one electrode to the other. And we also use catalyst in fuel cell that speeds the reaction of the electrodes. Here hydrogen is the basic fuel of fuel cell, but in fuel cell, hydrogen fuel cell, besides hydrogen we need also oxygen. And one great appeal of fuel cell is that they generate electricity with very little pollution. That means when hydrogen and oxygen in hydrogen fuel cell, hydrogen and oxygen react with each other and produce electricity, and it also produce harmless byproduct, that means water and some heat. So we can say in hydrogen fuel cell, so very little amount of pollution occur, or otherwise we can say there will be no pollution in hydrogen fuel cell occur, because hydrogen and oxygen react with each other and form water molecules and some heat, and during this reaction electricity produced. So this is environment friendly battery. We can say this is environment friendly one kind of battery. So now types of fuel cell. One is phosphoric acid fuel cell, molten carbonated fuel cell, proton exchange membrane fuel cell, alkaline fuel cell. Usually hydrogen fuel cell is in alkaline fuel cell. Basically we discuss about hydrogen fuel cell. And last one is solid oxide fuel cell. So at first, phosphoric acid fuel cell, you can see in this picture phosphoric acid fuel cell. About phosphoric acid fuel cell, phosphoric acid fuel cell, the use phosphoric acid as an electrolyte. We use phosphoric acid. Efficiency range from its efficiency range is 40 to 80%, and operating temperature is between 150 to 200 degrees Celsius temperature, and existing phosphoric acid cell have output up to 200 kilowatt, and 11 megawatt units have been tested. So this is very efficient fuel cell. Another fuel cell is molten carbonated fuel cell. In molten carbonated fuel cell, we use high temperature compound salt. For example, like sodium carbonates or magnesium carbonates. as an electrolyte. So as electrolytes we use carbonate, that dissociates or melted at high temperature. So its efficiency range is 60 to 80% and operating temperature is 650 degrees Celsius. Usually with output up to 2 megawatt. Megawatt has been constructed and design exists for units up to 100 megawatt. So this is also very efficient fuel cell. Third one is proton exchange membrane fuel cell. Proton exchange membrane fuel cell work with a polymer electrolyte in the form of thin permeable sheet. So here you can see the proton exchange membrane fuel cell, and its efficiency is about 40 to 50%. So, and in operating temperature is 80 degrees Celsius temperature, and cells output generally range from 50 to 250 kilowatt. These cells operate at a low enough temperature. You already know that 80 degrees Celsius temperature. So we can use proton exchange membrane fuel cell in our home or cars, but their fuel must be purified. Main criteria is fuels must be purified, and platinum catalyst is used on both sides of the membrane. In both sides of this membrane, you know that here is a polymer exchange membrane. In both sides of this membrane, we use platinum catalyst in case of proton exchange membrane. So proton exchange membrane cell work with a polymer electrolyte in the form of thin permeable sheet. Its efficiency is 40 to 50%, and it works at low temperature. I repeat it, it works at low temperature, so it is very useful to use in home and cars also. But here is a condition: the fuel must be purified, and we need to use platinum catalyst on the both sides of this proton exchange membrane. Now, alkaline fuel cell. In alkaline fuel cell, we use basically potassium hydroxide as a electrolyte. We use electrolyte as a potassium hydroxide. You can see in this picture of alkali fuel cell. In electrolyte, we use potassium hydroxide as electrolyte, and its efficiency is about 70%. So it is very highly efficient fuel cell, and its operating temperature is 150 to 200 degrees Celsius temperature, and its cells output range is 300 watts to 5 kilowatt. Alkali cells used in Apollo spacecraft to provide both electricity and drinking water. They require both pure hydrogen fuel, however, and their platinum electrode catalysts are expensive, and like any container filled with liquid, they can leak. So here is we can use alkali cells that were used in Apollo spaceship to provide both electricity and drinking water. How electricity and drinking water? When hydrogen and oxygen react with each other, it produces electricity, and this electricity is used, and as a byproduct that is formed by the reaction of hydrogen and oxygen, we get water. So this water will be used as drinking water. So we can use this in two ways: in case of electricity, in finding of electricity, and in case of also drinking purpose. So alkaline fuel cell is very efficient. Its efficiency rate is 70%, and we use basically potassium hydroxide as electrolytes. And last one is solid oxide fuel cell. Solid oxide fuel cell is hard and ceramic compound of metals like calcium or zirconium oxide. Basically, calcium or zirconium oxides are used as electrolyte, and its efficiency is 60%, and operating temperature is very high, that is 1000 degrees Celsius temperature, and cells output is 100 kilowatt. So it is operate in high temperature. At such high temperature, a reformer is not required to extract hydrogen from the fuel, and waste heat can be recycled to make additional electricity. So we get electricity, and due to excess temperature, this excess temperature is also used for additional electricity. Now, parts of the fuel cell. In practice, many fuel cells are usually assembled into a stack. That means cell or stack, the principle are the same. The purpose of the fuel cell, we know that our main purpose of the fuel cell is to produce electricity or electric current, and that is directed outside the cell to do work. such as powering an electric motor or illuminating a light bulb or a city. Because of the way electricity behaves, this current returns to the fuel cell and completing the electrical circuit. So here I discussed on alkaline fuel cell. Basically, usually I discussed about hydrogen fuel cell, and hydrogen fuel cell is one kind of alkaline fuel cell. So there are four main parts of a fuel cell. You already know that. One is anode, cathode, catalyst, and proton exchange membrane. That means in proton exchange membrane we use basically electrolyte. The anode. What is anode? In this picture you can see a zip picture. You can see anode, cathode. There is a proton exchange membrane. So the anode is the negative post of the fuel cell. This is the anode. Anode is the negative post of the fuel cell. It constructs the electrons that freed from the hydrogen molecule when hydrogen molecule is come in contact with the anode, and in anode we use basically platinum electrode, platinum as a catalyst, and when hydrogen fuel cell come in contact in anode, it produce hydrogen proton. It produce proton and electron. That electrons will travel through the external circuit. Electrons will travel through the external circuit, and it produce hydrogen, and excess hydrogen is get back from this way, and this hydrogen when dissociates into proton, this proton travel through the proton exchange membrane. This travel through this proton exchange membrane. You can see in this picture these protons are travel through the proton exchange membrane and come in cathode. So in anode, anode is the negative post. It conducts the electrons that are freed from the hydrogen molecule to the external circuit. It has channels east into it that disperse the hydrogen gas equally over the surface of the catalyst. Now, what is cathode? In hydrogen fuel cell, cathode is the positive post of the fuel cell, and it has also channel east into in such a way that it distributes all the oxygen of the surface of the catalyst. It also conducts the electrons back from the external circuit. Here you can see from anode you get electricity, and this electricity come into cathode through the external circuit. So cathode conducts the electrons back from the external circuit to the catalyst, where they can recombine with the hydrogen, that means proton, hydrogen ion, that means proton, and oxygen to form water molecules and some heat also. And the catalyst. So catalyst is a special material that facilitated the reaction of oxygen and hydrogen. It facilitated the reaction. It is usually made of platinum powder, very thinly coated onto carbon paper or cloth. So in anode we use platinum powder, and in cathode we use nickel powder. The catalyst is rough and porous so that the maximum surface area of the platinum can be exposed to the hydrogen or oxygen. We know that already. If surface area increases, the reaction occurs spontaneously, or reaction occurs by reaction rate, or reaction rate is very high. So catalyst, we use rough and porous catalyst so that the maximum surface area of the platinum or nickel catalyst occur, and that exposed to the hydrogen and oxygen to reaction fast. So platinum coated site, you can see in this platinum coated site of the catalyst faces to the proton exchange membrane. Now, what is proton exchange membrane? In fuel cell, you can see generally alkaline fuel cell, generally we use potassium hydroxide as the electrolyte in proton exchange membrane. And a proton exchange membrane is a semi-permeable membrane, usually made from isomer and designed to conduct only protons, not other ions. It only conducts protons. Here you can see it conducts only protons, and designed to conduct proton while acting as an electronic insulator. That means no electron is passed through the proton exchange membrane. Electrons will pass through the external circuit. But no electrons are passed through the proton exchange membrane. Only protons are passed through the proton exchange membrane. So proton exchange membrane can be made from either pure polymer, it can be formed by pure polymer membrane, or form composite membrane. For example, Teflon and Nephron. Here is you can see the structure of Teflon, and this is the structure of Nephron. So this is very important. Here you have a question, what is proton exchange membrane? So I think now it is clear to you what is proton exchange membrane, how it is formed, and how it works. So I think it is very clear to you. And this is a specially treated material that only conducts positively charged ion, that means proton, and the membrane blocks electrons. That means no electrons can travel through the proton exchange membrane. Electrons are travel through the external circuit, only protons are travel through the proton exchange membrane. So I think it is clear to you. So how do fuel cell work? Here you can see fuel, that means we use hydrogen in hydrogen fuel cell. That means hydrogen is first transported to the anode of the cell, then it undergoes chemical reaction, that means anode reaction. When undergoes anode reaction, it splits into proton and electron. Electrons are travel through the external circuit and it reaches to the cathode, but proton are travel through the proton exchange membrane. So protons are travel through the proton exchange membrane, and electrons are passed through the external circuit and reach to the cathode. When electrons and proton both are reached to the cathode, and from air we pass oxygen, and in cathode, due to the presence of catalyst, proton, oxygen and electrons recombine with each other and form water molecule. So this is the basic concept of this fuel cell, and in this way a fuel cell basically works. So now chemistry behind the fuel cell. Oxidation. At the anode of the cell, a catalyst, that means platinum powder, is used to separate the proton from the electron in the hydrogen fuel. Here hydrogen splits into proton and electron. Proton pass through the proton exchange membrane and electron pass through the external circuit. And in reduction, at the cathode of the cell, the second catalyst we use nickel. I repeat, at anode we use platinum catalyst, and at cathode we use nickel catalyst. And due to the presence of nickel catalyst, at cathode, proton, oxygen and electron recombine with each other and form water molecules. And its E cell equal to 0.68 volt. Here is a graphic showing working of fuel cell. You can see it very clearly. From our fuel source, we pass hydrogen from the tank, and due to the presence of catalyst at anode, it splits into a proton and electron. So proton passes through the proton exchange membrane, and electrons are passes through the external circuit. And due to the presence of catalyst, nickel catalyst in cathode, oxygen from the air, proton from the proton exchange membrane, and electron coming from the external circuit recombine here and form water molecules. You can see it forms water molecules here. So this is the, I think it is very clear to you how a fuel cell works and what is the chemistry behind a fuel cell. So uses of hydrogen fuel cell, there are many uses. For example, power sources for vehicles such as cars, trucks, buses, and even boats and submarines also. For power source for vehicles, we can use fuel cells. Power sources for spacecraft, remote weather station, and military technologies, we can also use fuel cell. We can also use fuel cell in case of batteries of laptop, smartphone, etc. If we need uninterruptible power supplies, we can also use fuel cell. So now advantage of hydrogen fuel cell. The cell run continuously until the reactant supply is exhausted. That means continuously supply of electricity. If you pass hydrogen and oxygen continuously, then it continuously produce electricity. So it will never dead. Water is produced as byproduct, which is very environment friendly. So our byproduct is also very invasive. So there will be less air pollution. There will be no pollution occur in case of fuel cell. The efficiency of this fuel cell is very high, and it's about 70% of chemical energy of the fuel are converted into electric current. So its efficiency is very high. On the other hand, in a modern power plant, only 45% chemical energy is converted into electric power. So fuel cell, in case of fuel cell, we can convert it at a 70%. That means it is highly efficient than modern power plant. So we can say that this is the advantage of fuel cell. It is free from pollutant. You already know that we, due to the reaction of oxygen and hydrogen, we produce water, heat, and electricity. And water as water friendly. Water is our environment friendly. So it is free from pollutant and environment friendly. And the electromotive force of the fuel cell is 0.6 to 0.7 volts. So a series of fuel cell contributes fuel cell stack. So lot of electricity, a huge amount of electricity will produce from a fuel cell stack. And hydrogen fuel cells are light and can be easily transported. So you can easily transport hydrogen fuel cell from one place to another. So this is the advantage of hydrogen fuel cell. Now you can compare the advantage or disadvantage of fuel cell and battery. In a fuel cell, an electrical energy conversion, a fuel cell is an electrical energy conversion device. So a fuel cell converts the chemical hydrogen and oxygen into water. In this picture, you can see hydrogen and oxygen form water molecules, and in the process, it produces electricity also. But in case of battery, a battery has all of its chemical stored inside. So in a battery, all chemicals are stored in its inside, and it converts those chemicals into electricity too. So this means that a battery eventually goes dead, and you either throw it away or recharge it. But with a fuel cell, chemicals continuously flow into the cell, so it never goes dead. As long as there is a flow of chemical into the cell, the electricity flows out of the cell. So battery, if we use battery, one day it will goes dead. But fuel cell, if we continuous our supply the fuel, that means hydrogen and oxygen, it continuously produce electricity. So it will never goes dead. But battery will once it goes dead. So today we learned about the fuel cell, different types of fuel cell. We know about the 5 types of fuel cell, the formation of fuel cell, basic structure of the fuel cell, the chemistry behind fuel cell, the advantage and disadvantage of fuel cell and battery. So if you have any question, please write it in comment box. Later on I try to solve it. So I have a home task for you. What is a fuel cell? What is a battery? How does fuel cell technology work? Analyze the advantage and disadvantage of fuel cell and battery. So thank you very much for your participation. I want to say you again that you must stay at home, maintain your family, maintain your social distance, wash your hands regularly, and you must avoid touching your eyes, nose, mouth by your hands. And I want to say you that you make your family member conscious about novel coronavirus COVID-19. Make your lesson properly and make the best use of your time. With this hope, I am conclude here. Thank you very much.